What if I told you that time, the thing we trust most, the very fabric upon which we weave our lives, might not be what it seems? What if our perception of time is merely a construct, a convenient illusion? We build our lives around clocks and calendars, meticulously planning each day, each week, each year, trusting their steady rhythm, their unwavering precision to guide us. But what if that rhythm is just a local illusion, a trick of the light, a story we use to make sense of a much stranger universe? A universe where time might flow differently, or perhaps not even exist in the way we imagine. This isn't just philosophy, pondering the abstract nature of existence, it's at the heart of modern physics. The very laws that govern the cosmos challenge our fundamental understanding of time. For centuries, we imagined a single universal clock, a cosmic metronome ticking for everyone, everywhere, a constant and unwavering measure of existence. But Einstein revealed a shocking truth, a paradigm shift that shattered our classical notions. Time is personal, flexible, and can stretch or shrink relative to your motion and the gravity around you. Climbing a mountain or orbiting Earth, experiencing different gravitational forces and velocities can literally change how your future unfolds, even if by the tiniest fraction of a second. Gravity, the force that grounds us, the invisible hand that shapes the cosmos, secretly shapes the flow of time, bending and warping it in ways we are only beginning to understand. This isn't science fiction, speculative tales of time travel and alternate realities. This is our universe, the one we inhabit, a place where the rules of time are far stranger and more wonderful than we ever imagined. By questioning time, by daring to challenge our most deeply held assumptions, we question reality itself, probing the very nature of existence. Prepare to have your mind bent, to have your perceptions challenged, as we peel back the curtain on the cosmos, revealing the secrets hidden within the fabric of time. Your personal clock may be ticking, measuring out your existence at a different rate than everyone else's, subtly influenced by your unique circumstances. The journey into the nature of time, this exploration of the cosmos, is a journey into the nature of reality, a quest to understand the fundamental laws that govern everything. So, let's begin. Let's embark on this adventure together. What is time? What is this elusive dimension that shapes our lives? The answer is more shocking than you think. Prepare to have your understanding of the universe transformed. Our lives in the modern world are inextricably linked to the concept of time. Our days are ruled by time, alarms, those insistent sounds that jolt us awake, dictating the start of our day, schedules meticulously planned and often overbooked, deadlines, those looming pressures that push us to our limits, shaping our work and personal lives. Civilization depends on a shared sense of now. Without it, coordination would be impossible, and society as we know it would crumble. Early humans, lacking our sophisticated tools, tracked days by the sun, observing its path across the sky, and seasons by the stars, charting the constellations and their movements to predict the changing of the year, creating our first clocks, rudimentary devices that mark the passage of time. The Earth's spin gave us days, the consistent rhythm of light and darkness, its orbit years, the grand cycle of seasons marking the passage of time on a larger scale. These cycles felt absolute, a fundamental truth of the universe, the same for everyone, regardless of location or circumstance. Newton formalized this idea, the concept of absolute time, time as a river, a relentless and unstoppable force flowing at a constant rate everywhere, a universal metronome ticking in perfect synchronicity across the cosmos. For over 2 centuries, this Newtonian view reigned supreme. This universal clock was unchallenged. It was the bedrock of our understanding of the universe. But as we built faster machines, pushing the boundaries of technology and looked deeper into space, peering into the farthest reaches of the cosmos, cracks appeared. The seemingly unshakable foundation began to crumble. Newton's steady river of time, once considered an immutable truth, turned out to be a winding stream, its course far more complex than we imagined, its flow altered by speed and gravity. Time, it seemed, was not so absolute after all. The universe, it seems, in its vastness and complexity, is more subtle than our everyday experience. The reality at the quantum level is far removed from our macroscopic world. Our synchronized world, built on precise timing and coordination, is built on an idea that breaks down at the extremes. The closer we look, the more the illusion fades. The deeper we look into the fabric of reality, the stranger time becomes. It twists, bends, and even seems to stand still. What we thought was absolute, a fixed and unyielding constant, is actually relative, dependent on perspective, speed, and gravity. The clock on your wall, a familiar and comforting presence, is just one story, a simplified version of a much grander narrative. In a universe full of surprises, a cosmos where the rules are constantly being rewritten. And that story, the true nature of time, is about to get a lot weirder. Prepare to question everything you thought you knew. In the early 1900s, a young patent clerk named Albert Einstein, working in the quiet of the Swiss patent office, was about to unleash a revolution upon the world of physics. Little did anyone know this seemingly ordinary man was on the verge of completely reshaping our understanding of space and time. He dared to challenge the long-held beliefs of classical physics, shattering Newton's universe, a universe built on the idea of absolute time and space. Einstein's theories would soon reveal a reality far stranger and more fascinating than anyone had previously imagined. He asked a deceptively simple question: what if you could ride a beam of light? This thought experiment, seemingly innocent, was the key that unlocked a new understanding of the universe. His answer: time is not absolute, a concept that flew in the face of centuries of scientific thought. It was a radical departure from the notion of a universal clock ticking uniformly for everyone, everywhere. It's relative, dependent on your motion and your position in the universe. This simple word relative changed everything. Einstein's special relativity, published in 1905, laid the foundation for this revolutionary understanding. It made the speed of light the only true constant, an unyielding benchmark against which everything else is measured. This constant speed became the cornerstone of his theory. To keep light's speed fixed, regardless of the observer's motion, something else had to give. Time itself must bend, stretch, and compress, adapting to maintain the constancy of light. This was a truly mind-bending concept. If you travel fast, approaching the speed of light, something extraordinary happens. Your clock ticks slower relative to someone who is not moving as fast, a phenomenon known as time dilation. This means that your experience of time is different than someone standing still. Imagine two synchronized clocks perfectly in sync at the beginning of an experiment. One stays on Earth, serving as a control, a fixed point of reference. The other rockets away, embarking on a high-speed journey through the cosmos. When the traveler returns, something remarkable has occurred. The traveler returns younger than their earthbound counterpart. Their clock behind, a tangible demonstration of the effects of time dilation. This isn't a trick. It's not a mathematical illusion or a theoretical abstraction. It's reality, confirmed by countless experiments and observations. Motion through space, specifically high-speed motion, has a direct and measurable impact. It affects your journey through time, altering the rate at which you experience the passage of moments. The faster you move relative to a stationary observer, the more pronounced this effect becomes. The faster you move, the slower you age, a consequence of time dilation that has profound implications. Building upon special relativity, Einstein's general relativity took these concepts even further. He proposed that gravity isn't a force in the traditional sense, like electromagnetism or the strong nuclear force. Instead, it's a warping of space-time, a distortion of the very fabric of reality caused by mass and energy. Mass curves the fabric of reality, creating what we perceive as gravity. Imagine a bowling ball placed on a trampoline. It creates a dip, a curvature like a bowling ball on a trampoline. This curvature affects everything around it, bending both space and the path of light. Gravity bends both space and time, slowing down the passage of time in regions of strong gravity. The deeper the gravity well, the stronger the gravitational field, the more pronounced this effect becomes. The deeper the gravity well, the slower time flows, a consequence of the curvature of space-time. With these revelations, the universal clock was gone, shattered into countless individual experiences of time. It was replaced by a universe where time is personal, a universe where each individual experiences time differently depending on their motion and their location in the gravitational landscape. Time dilation, motion slows time, isn't science fiction, it's fact. Drive a car and your clock ticks a tiny bit slower than someone standing still. At everyday speeds, the effect is minuscule, but near light speed, it's dramatic. On a train at 99.9% the speed of light, a year for you is 22 years for those left behind. Space and time are woven into space-time. Moving through space means borrowing from your journey through time. We see this with muons, particles created in the atmosphere. They live microseconds, but moving near light speed, their clocks slow, letting them reach Earth's surface. Time dilation is real, measured, and shapes the universe. The faster you move, the more you travel into the future. Even if you don't notice, your personal clock is always unique. The universe keeps its own strange time. Gravity also bends time. The closer you are to a massive object, the slower your clock ticks. Atomic clocks on mountains run faster than those at sea level. Einstein was right. Even your head ages faster than your feet. GPS satellites prove this daily. Their clocks run faster in weaker gravity, but slower due to their speed. Engineers must correct for these effects, or GPS would fail. Our technology and our lives depend on understanding that gravity warps time. Time is not just a number, it's shaped by the mass beneath your feet. The twin paradox: one twin stays on Earth, the other rockets to a distant star and back. The traveler returns younger, her clock ticked slower. The key is acceleration. The traveling twin changes frames, breaking the symmetry. This isn't just theory. Astronauts on the ISS age milliseconds less than us. They've literally traveled into our future. Near a black hole, time slows to a crawl. For a distant observer, you'd seem to freeze at the event horizon. For you, time feels normal as you cross the point of no return. Black holes are the ultimate time machines, warping moments almost beyond recognition. The closer you get to extreme gravity, the stranger time becomes. Our universe is a playground for time's flexibility. Every journey through space-time is a journey through time itself. The rules are stranger than fiction. Interstellar brought real physics to the big screen. Near the black hole Gargantua, time slows drastically. An hour on Miller's planet equals 7 years in orbit. The crew's short mission cost them decades. When they return, their colleague has aged 23 years. Cooper watches his children grow up in minutes. He's become a ghost in their lives. The film makes relativity personal, showing time's power to shape relationships and memories. While some ideas are speculative, the core, gravity stretching time, is real science. Interstellar reminds us the universe's laws are both magnificent and merciless. If time is so flexible, is it even real? Some physicists say our sense of now is an illusion. Reality is a block universe where past, present, and future all exist at once. Time doesn't flow, it just is. Our consciousness moves through space-time like a movie reel, frame by frame. Other theories suggest time is made of indivisible chunks, or that it emerged from a timeless reality at the Big Bang. We're so embedded in time, it's hard to imagine existence without it. But the universe may not care about our intuition. Time's true nature remains one of the deepest mysteries. So is time real or an illusion? Maybe that's the wrong question. Time's effects are measurable. GPS and astronauts prove it's no illusion. Time allows change, motion, and life. The arrow of time, driven by entropy, gives the universe its story. Each of us lives in our own bubble of time, shaped by gravity and speed. There's no universal clock, just the tapestry of space-time. Time is a dimension, flexible and personal, woven into the cosmos. It's the river on which reality flows, speeding up and slowing down across the universe. Time is more than a measure. It's the very shape of existence, and its mysteries are far from over.